Greetings. I'm Captain Kevin Smith, and I would like to start off by thanking the organizers for the International Symposium of Aviation Psychology for affording us this opportunity, giving us a space to do this video. And the title of this talk is Mission Ready Adaptive Systems. And we are going to discuss over the next half hour, 45 minutes, what that means and why that is important today in this aviation environment. Mission Ready Adaptive Systems are a subset of a larger category of systems. And they typically will go by the name of complex adaptive systems. Complex adaptive system is pretty much what it says. It is complex, of course, but it is also adaptive. And the reason why it's adaptive is because if it's going to persevere, if it's going to survive, it has to be robust. And if it's not adaptive, then it, of course, is not robust. Now, I am proposing that this is the new performance model that we should adopt for crew station design. Specifically, what I want to discuss with you today, how do we develop optimized display features for mission critical operations. Again, I'm Captain Kevin Smith, and I do quite a bit of speaking. I'm an author of a number of books. We'll talk about that very, very briefly. And I do some design consulting also. What I do now, previously I had been involved in lots of projects, and also I was a military and commercial pilot for 40 years of active flying. I started my career flying fighters for the U.S. Navy, and I got involved in the Top Gun program, and what our problem was is we had to figure out how to optimize flight crew performance very, very quickly in the air combat arena. The reference document for this discussion is here. This is a book that I authored along with my co-author, Stefan LaRue, Mission Adaptive Display Technologies and Operational Decision Making in Aviation. That's available, published by IGI Global. Again, that's the reference document for this discussion. The story, I'm going to start off this discussion today with the story. This is an actual occurrence that I experienced and that brought me to this position that I am now, because it's one of those case studies, if you will, or one of those experiences where you gain some insight into things that are kind of difficult to understand, and hopefully this insight that we were able to gather and acquire proved to be helpful, and I'm going to show you how helpful it was. The story deals with optimizing flight crew performance in modern airline operations. Again, my experience has been military and commercial operations, performance optimized crew station design. I did some work on the F-22 project during its initial phase, looking at the crew station for that, and advanced aircrew training. I got involved in that along the way. The story begins with a problem we had with the Boeing 767 fleet. And the problem was that the flight crews were not performing very well during the transition training. I was brought in to join a task force to figure out why, come up with recommendations, implement the recommendations, and to try to fix the problem. And we eventually did. We got together and we figured out what the problem was. And it's kind of an interesting story because the problem was not what we thought it was, and the solution was not what we thought it should be. So the 767 fleet included, of course, the 757. It's a combined fleet. Also, in the mix here was the Boeing 777. That was a new airplane that was being introduced at about the same time, and so that had some influence on what we were trying to accomplish, and that played a role in this problem-solving initiative. What was the problem? And here was the key to our success, which was we didn't really know. We kind of had some ideas about the problem or what was happening, but we didn't actually know the root cause, didn't really have a firm understanding of what the problem actually was. So it took some time, but I think we found out what the problem was. Again, it wasn't what we expected. What was the problem? Well, the pilots had performance difficulties, but we didn't think it was necessarily a pilot issue or exclusively a human issue. We wanted to look at the whole system. We wanted to look at how the system was set up, whether it was optimized to help the pilots perform well on a continuous basis. And, you know, as it turns out, the system had some issues that needed to be fixed, and once we did that, we saw some dramatic improvements on the pilot performance side. So we're going to be talking about that. The difficulties were longer training time. They were recurrent training stress. Skill retention was a big problem. And of course, there was very little work being done at the time to deal with best practices. Problem space awareness. The big problem that we discovered, everybody thought they knew what the problem was, but we had to define it and clarify it. And the big problem was that we were dealing with a highly complex environment, and we had to make sure that we understood what that meant. And the key was the critical operational concerns. So we had to list them, we had to articulate them, we had to raise them up to a level of awareness that everybody understood what the critical operational concerns were. And in particular, information management became one of the keys to our concerns. There was a lot of information being produced by these modern airliners and the glass cockpits. A tremendous amount of information was entering the flight deck environment, but how do you manage such a thing? And were there mechanisms in place that would help the pilot manage the information coming in? The most serious problem, and this was not a surprise to all of us, but it was generally a surprise to many, was that critical flight maneuvers, that portion of the mission critical environment, critical flight maneuvers were not being adequately addressed. And that turned out to be one of the keys to our success. Once we were able to address those in a meaningful way, it proved to be quite helpful. Now, the overall pilot performance with respect to critical flight maneuver performance was declining. And that was the crux of the problem that we were dealing with. Training and operations were not optimized for mission critical operations. And that is where we focused our attention. What is a mission critical environment? What does it mean when something is mission critical? So we looked at it with respect to flight operations and thought about it in terms of critical flight maneuvers. Okay, that's part of it. What are the critical flight maneuvers? Of course, all the engine out operations, all the escape recovery maneuvers, and there's a number of those. And of course, the operations in terrain critical situations or in terrain critical airports in particular. These could all be classified as critical flight maneuvers. And the solution that we, the solution we settled on was, if in fact we have to perform these critical flight maneuvers, is there some way that we can be helpful to the flight crews who have to deal with this in a very time-sensitive, high workload environment under, in some cases, extreme levels of stress. And so we had to figure out what we could do, if anything, to help the flight crews. And we also needed a way to think about what was essential. Okay, so here we have the solution space, all right? So we have the technical, we handled that. We looked at all the technical aspects of the solution space. There's a lot of them. We looked at the flight crew, what they do, what they had to be certified to do, what they were required to do, all of that stuff. We looked at the operational side and discovered that there's little attempt at risk management. There was some in CRM, but not a lot. And the information, energy, and trajectory were not addressed very much, although they were addressed in some form or fashion. But the critical flight maneuvers were not actually being addressed essentially at all. They were just thrown out there and said, and the expectation was that the flight crews somehow were going to be able to internalize this and optimize their performance, but they were not actually taught how to optimize their performance. So the big picture was the display features were not optimized for mission critical operations. So that was the key here. And that's kind of the focus that we took. That was the strategy that we identified, and we put our energy into that initiative, looking at the display features or what we could do to provide the crews with performance aids in real time. So the big picture problem again was that display features were not optimized for mission critical operations. And that was, it turns out to be a huge problem. Again, mission critical is those things that are complex, those things that are urgent, they must be done quickly, and the performance of them, the time available is very limited. We call it a time compressed environment. So you can see here that this display is in fact, you could argue that it is optimized for normal flight operations, but is it optimized for mission critical operations? And the answer is no, it's not. And we'll cover that as we go forward. All right, so normal operations, here we have the list of normal operations, normal takeoff, departure, climb, those kinds of things on a normal day. Now, I found out after 40 years of flying, there are very few days that are totally normal. There's always something that you have to deal with. I remember flying, one time I was flying into San Diego from I think someplace in Texas. And it was a beautiful day, and I thought to myself, boy, this is a great day to fly, and everything is going great, and the weather is perfect. And we passed Las Vegas, and I got a ding from my first flight attendant. A passenger has had a heart attack. So we had to divert, all right? We had a medical divert, just out of the blue, all right? Just, so no, you don't expect it to be normal. You kind of expect something to happen. All right, so mission critical operations, critical flight maneuvers, of course, escape maneuvers, recovery maneuvers, and avoidance maneuvers. Those are the kinds of things we need to be prepared for, and we need to look at ways that we can be helpful to the flight crews that actually have to perform such a thing. Again, critical flight maneuvers, the engine out precision approach. Now, this particular display is optimized for a normal approach, but as we're going to see in a few minutes, it is actually not optimized for an engine out approach. And that is one of the things that we had to address. Critical flight maneuvers, again, includes engine out operations, non-precision approach, and escape recovery maneuvers. Here you can see what an escape recovery maneuver, this is a terrain escape environment on the left, engine out operations on the right. And the solution, of course, was, in our view, was performance aids. And now, performance aids hopefully could be real time. They could be done just prior to the event, or they could be accessed in lots of ways today. But hopefully they are embedded within the cockpit environment. Critical flight maneuver performance aids, that was the key. That's what we had to deal with, and that is what we focused our attention on. Again, what is a critical flight maneuver? Critical flight maneuver is something that must be performed. It has to be performed quickly, and it has to be performed with precision. And the precision is pretty important because there's not a lot of tolerance when you're dealing with some of these escape recovery or terrain avoidance maneuvers. There's really not. So it's got to be performed with precision. Again, the takeoff with a T procedure, that is, if in fact that happens, that's a critical flight maneuver. That has to be performed with precision. Some of these T procedures are very complex. For example, the T procedure out of Las Vegas, if you're heading westbound, is pretty complex. If you ever want to see something that is kind of mind-boggling, take a look at that procedure. And you think, whoa, really? Am I prepared to do this? Pretty serious stuff. And what help do I have? Who's going to help me? So, displays optimized for mission critical operations. Here we can see normal operations on the left and mission critical ops on the right. You notice that there's no difference. However, the right screen should be different if it in fact is addressing itself to mission critical operations. And that is the whole point of this discussion today. Critical flight maneuvers, what can we do? Here's a decision point that we had. And this goes all the way back to my work that I did on the initial design, cockpit design for the F-22 for the Air Force. We can look at all of these maneuvers in isolation. Okay? And that's typically how we kind of address things. But I didn't like that. And I don't know, maybe that's good enough. But I didn't like looking at all these maneuvers as isolated events, as one-off events that were not connected to one another. Each one had its own unique characteristics, and therefore it had to be treated distinctly separately from each one. I never thought that that was the way to go. I always thought that there were certain common characteristics for all critical flight maneuvers. And I'm going to make the case that there is common characteristics. So it ought to be taught as a training module that includes a number of critical flight maneuvers instead of being taught individually. A lot of the critical flight maneuver performance aids could be embedded in what we call the ICAS, which is the center displays, the upper and lower ICAS. You can see here in this airplane, it looks like it's a 4-engine airplane, I'm not sure. Yeah, I guess it is. There's four engines up there. So I guess it is a 4-engine airplane, all right? So anyway, so that it's got an upper and lower ICAS. And that's where a lot of these aids could be embedded in. Now, if we are in fact going to address critical flight maneuvers holistically in terms of a training module or in terms of their common characteristics, what do you want the system, either it's a training system or an onboard system or both, what do you want the system to look like? What is the architecture of the system? I know that some of this stuff is a bit outside the box, but I don't like treating things separately and individually. I never thought, when I was involved in training pilots, I never thought that that was a good way to go. I always thought that there had to be some kind of common denominators here that could be brought to bear across all of these dimensions that we're talking about. So we came up with this idea of a architecture, if you will, or a holistic, overarching thing that contained all of these critical flight maneuvers within the context of mission critical operations. And we had to give it a name because that's the way we think, right? So it's kind of like Alexa is a name for, what is it, Amazon voice activated thing you do, right? So we gave it a name. We gave it Erica, all right? And Erica is the performance aid package that we could install in the airplane, and we could also incorporate it into our advanced airline pilot training curriculum. But again, it could reside in the ICAS system. So ERICA stands for Event Response Integrated Knowledge Advisor. It's just a way for us to think about this as a package deal. Okay, so all critical flight maneuvers could be contained within this package, if you will, and you could then create this package and provide the crews with the resources contained within this. Now, the resources could be training, it could be documents, it could be training aids, it could be training videos, and it also could be embedded eventually in the system to operate in real time. So, ERICA stands for that. It includes precision maneuver guidance for all critical flight maneuvers. It also deals with operational decision making, or another term that's often used as operational risk management. It means the same thing. And also a mission performance evaluator, which is in fact a kinematic advisor. I know that is a kind of a highfalutin term, but kinematics is not often used, but I think it should be, because it deals with movement, deals with motion. And here we're dealing with something that travels through time and space, and we have to become more aware of that situation and that phenomena. Precision maneuver guidance. We're going to focus on that. We're not going to focus on the other two. We're going to focus on precision maneuver guidance. Precision maneuver guidance could be embedded within the onboard system that we call ICAS, and it could come up as a PIP, picture within a picture initially. So if you did lose an engine on takeoff, the airplane knows that. Right, so there are triggers already built into these modern airplanes. The airplane knows that it's lost an engine. And you could have it trigger this precision maneuver guidance, which we call the engine out terrain avoidance procedure, or the easy term that us pilots use is T procedure. So the T procedure could come up on the navigation, initially on the ICAS system, and then migrate over to the navigation display. Here is the precision maneuver guidance for the engine out ILS approach. You notice that there is a lot of things here, right? And this is the only way that approach can be executed with precision. And so on the left side, we notice the ILS indicators for each portion of that as we move into the cone of the ILS. We notice that there are certain things that trigger, there are certain things that must be done. Those are the trigger points by which these things must be accomplished. So that's all part of this precision maneuver guidance for this particular critical flight maneuver. Critical flight maneuvers, the target pitch attitude we discovered, and here's the common thread across all critical flight maneuvers. And this is what we discovered through lots and lots of operational testing, is that the pitch attitude must be known prior to maneuver execution. The machine can be helpful because the machine has a trigger. It can actually show you that. What we had to do is we had to rely on memory because we were doing cardboard mock-ups for this system. They were actually pretty useful. If you could bring in the cardboard mock-ups just prior to the simulator event, you'll find that the flight crews do much, much better. But the target pitch attitude must be known prior to maneuver execution. That's a common thread throughout all critical flight maneuvers. Again, one of the keys to success was, and still is, target pitch attitude. You have to know that. Now, some manuals say follow the flight director. That is very, very poor advice. We changed that in the airline that I was working for. We changed that entirely. We said that the flight director should be consulted but never blindly followed. And that was a huge breakthrough because the flight director sometimes will give you erroneous information, as we know from Air France 447. Here is another example. I'm just going to cover this very, very briefly here, but here's another example of what we're talking about. This happens to be the navigation display on a typical glass airplane, a modern airplane. And you notice this is normal operations. Okay, everything is going normally. You're flying somewhere could be over the ocean, oceanic operations. I think it might be. Now here is, let's say, a place where you want to know what your ETOPS divert field is, where it is in real time, and how do you get there. Okay, you notice that in this display, it should show you something that would help you in oceanic operations. It should, but it doesn't actually. This is what it should show you. Now this is an example of a proposed idea If you had to perform a mission-critical operation, which means an en route divert, and that's possible, particularly if you're doing long-range over-water operations, you kind of like to know where the divert field is on your map and the initial heading to take. Even before you got your navigation system up and running, you kind of need to start heading in that direction because there's not a lot of time. I'm just going to touch on a few things that are occurring right now in aviation. Hopefully the situation will be resolved soon. But right now, aviation is dealing with some difficulties. And we need to consider, as aviation professionals, we should consider how we could maybe be helpful in our thinking about what is occurring right now in aviation and what are the things that we ought to consider putting in place that could be helpful in the future. So we're going to talk a little bit about the situation right now with the 737 MAX and its difficulties. Right now the airplane is grounded worldwide. There's been a lot of efforts, crash program to get it back up. Hopefully it will get back up and start flying again soon. I'm very hopeful. I think we've got some really good people that have been brought into the process. My take on this, because I have considerable amount of expertise in the area of airplane design as well as training in flight crew performance, I would say that whatever system architecture we consider, we ought to consider something like this. Now, you've heard in the press, they talk about software issues and stuff. That's not a software problem. It's an architectural issue, and we need to deal with it at the architectural level, the system architecture. What should that look like? Well, I'm not saying this doesn't, because I don't have the inside track on this particular airplane. I did fly the earlier version of this airplane, so I'm very familiar with the 737. I've got thousands of hours in the 737 300 and 500. That is also a glass airplane. So I know how it flies and know what its limitations are and stuff like that. But if I was going to consider such a device to help in a high angle of attack situation, I would also consider what inputs these other things would contribute to the logic or the brain of this thing that they call MCAS. Does it have a brain? Ought to, right? It ought to have a brain. It ought to be thinking at some level. Could be low-level thinking, but there ought to be some thinking going on in terms of, should I activate when I get a GPWS warning? What do you think? Do you think it should activate if you have a GPWS warning? I would say probably not. Okay, because if you have a GPWS warning, what is the first thing that you must do as a flight crew? You must go to 20 degrees pitch attitude. Okay, that's a given. You have to go. Now 20 degrees pitch attitude is a very, very high angle of attack. It could be even stick shaker. It could be, all right? Do you want this thing activated when you're trying to escape terrain? No. You don't want anybody pushing down on the yoke. Low altitude pitch stall warning. There's other things you can, obviously, you want to have the system, this controller, you want to have it smart enough to understand the big picture, right? It needs to be smart enough to understand the big picture. And that's the whole idea behind what we're trying to do. It's the whole idea behind Erica. It's the whole idea behind all of this stuff is that, does it work in the real world environment? Does it actually capture the big picture and utilize it to help you optimize mission performance and achieve mission success. Here we can see some of the inputs and when it should be disabled. And it ought to be designed for mission critical operations. That completes this video. Thank you for listening.